All right, guys, we're going to start a new unit called bonding. So let's review our types of elements. So the entire periodic table is made of two types of elements: metals and nonmetals. So you learned about these in the last unit, and so on our periodic table, I'm going to draw that separation between your metals and nonmetals. So it goes from here, 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 here. At this point, I would pause the video and color in your metals and your nonmetals. I would suggest coloring your metals yellow and your nonmetals blue. That's just usually the colors that I use. All right. Now, just a reminder that hydrogen is a nonmetal, so make sure that you color your hydrogen the blue nonmetal. All right, go ahead and color. All right, so I colored my metals and my nonmetals. Okay, so let's do a quick review. Look for carbon. Carbon is the element symbol C. Is it a metal or a nonmetal? It's a nonmetal. Okay, what about sodium? Sodium is on this side here. Okay, that is a metal. Sn, which is tin. Tin is over here. That is a metal. Nb, neobium, is right here. Ooh, that is also a metal. Silicon is right here. That is a nonmetal. Hydrogen is over there. That is a nonmetal. It's on the metal side, but it's the only nonmetal. All right, so now let's talk about bonds. Okay, so recap on what a compound is. So a compound is a pure substance where you take two or more elements, remember two or more capital letters, and you combine them chemically. Okay, that chemical combination is called bonding. Bonding occurs because, remember, all elements always want to have that full outer shell so that it can have like a noble gas look to them, which is 8 valence electrons. So, atoms will lose, gain, or share electrons to get to that point. There are 3 different types of bonds, and so let's talk about each type. Ionic bonds is when you have a metal bonded to a nonmetal. So, electrons in ionic bonds are transferred. No, the blank is really small. Okay. Metals will lose electrons to look like a noble gas, and nonmetals will gain electrons. So it's like a win-win. One man's trash is another man's treasure. Some of the properties that ionic bonds have is that they're brittle, they have a high melting point, and they're also called electrolytes. We'll talk more about electrolytes next semester, so don't worry too much about that word. Covalent bonds are when you have a nonmetal bonded to another nonmetal. Here, electrons are shared, so sharing is caring. They're basically going to be holding hands, sharing their electrons. They're very opposite of your ionic bonds. They have a low melting point, and they're called non-electrolytes. The third type of bond, which we're not really going to talk about too much, is called a metallic bond. But you can see the word metal in there, so you can assume that it's when a metal is bonded to another metal. usually this metal is bonded to itself. That's like the most common type of metallic bond you will see. The most important vocabulary word you need to understand is what we call the sea of electrons. Basically, when a metal bonds to another metal, all the electrons get to float around like the sea. So basically, your metals are these like islands, and then all the electrons just surround it like the sea. Okay, so when you see this vocabulary term, sea of electrons, you have to think metallic bond. All right, so metallic bonds have two popular properties. One is easy to bend. Remember that is called malleability, so we'll just write malleable. Also, you can really thin them out to form wires, and we call that ductile. And they're also very conductive. Now, like I said, this is the only place we'll talk about metallic bonds. In the later notes, we're only going to talk about ionic and covalent. So don't forget about your metallic bonds here. Okay? All right, so I highlighted the different colors to match our periodic table that is in the top of our notes. All right, so next, let's use a trick to help us remember what the difference is between a metallic and a ionic versus a covalent bond. So metallic has the word metal in it, so think metal and metal. Here, if you think of I'm on CNN, this is a trick to help remember the difference between ionic and covalent. So the I stands for ionic. Ionic bonds is when a metal bonds with a nonmetal. Okay? Then CNN, the C stands for covalent. And then the N stands for nonmetal, bonds with another nonmetal. Okay, so using your periodic table, let's identify these compounds as ionic, covalent, or metallic. So our first element here is carbon. So look on your periodic table. Carbon is a nonmetal. Oxygen is also a nonmetal. So when you have a non and a non, right, then it must be a covalent bond. Okay, so I would pause here and try to fill out the rest of the chart, and then in just a moment, I'll post up all the answers. Okay, so here are all the answers. I would check yourself and make sure you know what kind of bond it is. Okay. The first type of bond we're really going to focus on are your ionic bonds. Okay, so the ionic bonds is when you have a metal with a nonmetal. Okay, so metals will lose electrons and nonmetals will gain. So remember, one man's trash is another man's treasure. So because positives and negatives attract, okay, the metal and the nonmetal will become attached together. So remember, when metals lose electrons, they're going to become cations. And when nonmetals gain electrons, they're going to become anions. So remember, cations are positive, anions are negative. And when you have a positive close to a negative, they are going to be attracted and get really, really close together. Okay, so if you look at this element right here, this one is an ion because it has a charge. The charge is in the corner right here. So the question is, what type of ion is it? Is it a cation or an anion? Well, here we see that it's a negative. So this must be an anion. Here we look at zinc. Does it have a positive or negative charge? No. then it's neither. It's a neutral atom. Okay, let's look at bromine over here. Here there's not a number, but there's still a negative here. The 1 is implied. So sometimes if you see it like this all by itself, the 1 is just imaginarily there. Okay, it's negative, so it's an anion. And over here, there's a 4 plus, which means it's a cation. All right. Great. Now that we know the difference between your anions and cations, then we can understand ionic bond formulas. Okay? When you see an ionic bond, which is a metal and a nonmetal, the metal is always written first, and the nonmetal always comes second. Because the metal comes first, the cation will always come first. Then the nonmetal anion will always come second. Okay? Now, if you identify and notice that there's a covalent bond, they do not have ions. Remember, they share electrons. So, think about it this way. When you have an ionic bond, it has the word ion in it. Ionic bonds will have a cation and an anion. It will have both. Okay, so ion, ion, ion. They all have to match. So for example, you look at this formula, Al2S3. You know that aluminum, according to your periodic table, is a metal. According to your periodic table, sulfur is a nonmetal. M, metal plus non, M and N, means that it's an ionic bond. So I'm going to write ionic. Now, I'm going to write here what each of the cation anions are. Remember, cations are positive and anions are negative. So I'm going to write aluminum because cations always come first. And now you're going to look at your periodic table. Okay, so looking at a periodic table, aluminum is sitting right here. Aluminum has 3 valence electrons. Remember, everyone's goal is to get to 8. So the question is, should I gain 5 to get to 8, or should I lose 3? Well, it is easier for everyone in this column to lose 3. Now remember, losing 3 negatives results in a positive 3 charge. Okay? Because you have 3 more pluses than minuses. So going back here in the corner, we're going to write positive 3 because it's going to lose 3 electrons. The anion is sulfur, so we're going to write an S. Now looking at your periodic table here, sulfur is right here. It has 6 valence electrons. And you ask yourself, okay, if I want 8, should I lose 6 or gain 2? Well, it's easier to gain 2. Now, if you gain 2 negatives, you're going to have a negative 2 charge because you have 2 more negatives than positive. So you're going to go back here and you are going to write negative 2. And that's your cation and your anion. Now, the next example is water, H2O. Hydrogen is a nonmetal. Oxygen is also a nonmetal. So, we know that a non and a non make a covalent bond. Covalent doesn't have the word ion in it. So that means it doesn't have a cation and it doesn't have an anion. So you skip it. Alright, so now I want you guys to fill out the rest of the chart. So I would pause here, fill it out, and then check your answers. It will pop up in just a second. Okay, so I would check all of your answers here. Pause if you need to.